In this video for section 7.2, we're going to introduce the idea of a sampling distribution. So whenever we're making decisions based on sample data and we don't have the data for an entire population, we have questions about the sample results. And so you can see these two examples here. Basically, the questions revolve around whether our sample data is close to the actual population results. So if we have a survey of visitors to a country, it finds the mean amount spent each day is $318.69. Now probably the entire population of 2 million people, the average is not exactly $318.69, but is probably somewhat close to that. And our question is, how close is it? Our second question is the sample size of 780 big enough to give us a good estimate of the population mean? That's not very much compared to 2 million, but is it enough people to give us a value that is close to the average amount that the entire group of 2 million people spends? Our second example, we're looking at furniture manufacturing. They're testing 150 pieces and they find that 15 of them have one or more issues. So this is 10%. Now, for the entire population of 6,900 pieces, is that exactly 10%? Is it close to 10% that would have the issues? And should we be testing more than 150 pieces? So anytime that we take a sample from a population, there are many possible samples, and each sample will contain different items. So anytime we do a sample of 150 pieces of furniture, we're going to get a different group of 150. So each group is going to have a different percentage of pieces that have errors. It could be 12% or it could be 8%, just depending on which pieces I end up pulling into my group. And the sampling distribution describes the distribution of possible sample outcomes. So some are going to be higher than the percentage that we get, some are going to be lower than the percentage that we get, or the average that we get, higher or lower than the average. So let's look at Theorem 3. It says if a population is normally distributed with mean mu and standard deviation sigma, the sampling distribution of the sample mean, x bar, is also normally distributed with the mean equal to the population mean. Now, this is a little bit confusing, but basically what it means is that if I were to take all possible samples, so for example, if I were to take all possible combinations of 150 pieces out of the 6,900 pieces, that would be a lot, but if I were able to take all of those combinations and find the percent that had issues for each possible combination, then if I were to take the average of all of those, it would be equal to the population average, or the average if I were to just look at the entire sample of 6,900 pieces. The standard deviation is a little bit different. Standard deviation of the sampling distribution is equal to the population standard deviation divided by the square root of the sample size. So basically what this means is that as our sample size increases, our standard deviation decreases. And remember that standard deviation measures variability. So the more items that we take into our sample, the less variability we have. So for example, if I were to only pull 10 pieces of furniture, I might find that it could be 20% or it could be 80% of the pieces that have issues, just depending on which pieces I chose. But the more pieces I pull, the less likely it is that I'm going to have those extreme values, and the more likely it is that I'm going to be close to the population percentage. So we're going to look at an example here. It's example 7.3. It says, at the West Side Drive-In, lunch orders average $12.50 per customer with a standard deviation of $5.50. For a random sample of 100 customers, what is the probability that the mean will fall between $12.25 and $13? We're going to do this problem using Minitab. So first we need to identify our mean and standard deviation. Our mean, or our average is what it's called here, is going to be $12.50. So the mean for our sampling distribution is also $12.50. Now for standard deviation, our standard deviation is $5.50. So what we need to do is make a correction here to the standard deviation. It's going to be 550 divided by square root of the sample size. So this is a key formula right here in this yellow box. Our standard deviation is divided by square root of sample size. So our sample size here is 100 customers. So we're going to divide 550 by the square root of 100. The square root of 100 is 10. That's easy to do, and 550 divided by 10 is 0.55. Now, usually your sample size is not going to be a nice perfect square number, so what you're going to end up here with is a long non-ending decimal. Generally speaking, you want to leave at least 4 digits after the decimal point, maybe even 5 or 6. If you round too abruptly, then this could cause your answer to be off a little bit, and it could cause it to be marked wrong. In my lab, even if it's not incorrect, it might just be off a little bit in terms of the decimal point. So what we want to know is what is the probability that the mean will fall between $12.25 and $13. And so these are x values. This is going to be a middle problem because we're looking for between two numbers. Our first x value is $12.25 and our second x value is 13. So we have all the information that we need to enter into Minitab to find the probability. Remember, we're finding probability on these problems, and it's going to be given to us on the graph. So go to View Probability. We're using normal distribution. Our mean is 1250 and our standard deviation is 55 cents. We have to enter the corrected standard deviation that we calculate by dividing by square root of the sample size. Click on Options. We're going to use middle, specified x value, and our two x values are 12.25 and 13. Click OK. And here's my graph. So I have my mean of 12.5, my standard deviation of 0.55, and I can see that my x values are going between 12.25 and 13, which is what I want. And I can see that my answer here appears above the red shaded area of 0.4936. So I would check to make sure of where I'm rounding, what my lab wants me to round if I'm doing this for a homework problem. But otherwise, my answer here I would write is 0.4936. So it's about 50% probability that the mean will fall between $12.25 and $13. And that should make sense because my average is right in the middle of that, and so it's pretty likely that my mean is going to fall within that kind of range. So when you're using Minitab in probability problems, some things to look for are what you are given in the problem. If you are given number of trials and probability of success, that's a binomial distribution problem. If you're given mean and standard deviation, then that's a normal distribution problem. And if you're given mean and standard deviation and a sample size, then you need to calculate the standard deviation to put into Minitab by taking the standard deviation that they give you and dividing it by square root of the sample size.